All right, boys and girls, this will be our potentially last lab for the year. So yay, you won't have to worry about that anymore. It is the Water Everywhere lab. It's on page 336. I'm gonna film this introduction and then I'm gonna click it to join the video together with the actual lab demonstration. So you don't actually have to conduct the lab. If you want to, this is one that you may be able to conduct in your house, but you don't have to. Okay, the instructions are very detailed, particularly for part A, using a model. Okay, part A, using a model, is the part that you would be modeling and you would be conducting. I did it very crudely in my kitchen, using just things that I had around the house. My suggestion to you is definitely watch the video because there might be some hints there, but also read along with the instructions. And the instructions might clarify anything that you might not understand in the video. Okay. The second part is graphing the distribution of water, and I made the graphs for you, so you are just going to have to do a little bit of analyzing of the graph and complete some of the graph. And then of course there's going to be questions. This little part right here is very important. So important that I put it into the lab. So just like all my other labs, all you have to do is the highlighted components. Okay, please do not print these off. My suggestion, do not print them off, or if you do print them off, do not print them in color because this will take up some of your colored ink and I don't want that to happen. I don't want your parents getting upset. And I don't want you wasting the ink for something that you don't necessarily have to do. Remember, you are more than welcome to simply just type on this. If you decide to print it off, print it in black and white. So your name and your class name, the problem, how much water on Earth is available for humans to drink. I'd like you to come up with a percentage for your hypothesis. Base it on what we already know about the water on the planet. Okay, so pretend we got 100% of the water on the planet. Of that 100%, how much do you think is drinkable? Okay, so that's pretty important. Materials and procedure, I just put, see the pages in your textbook. Observations. So the observations, you're just gonna make point form, just put a few observations on the demonstration that I conducted on the video. Doesn't have to be rocket science, just some of the things you saw. Now I don't want things like, I saw that your floor is brown. Okay, it has to do with the experiment. So part B, this is the data. It says provide a descriptive title of the graphs below. Data was taken from page 337 of the textbook, see below. So this is that very important piece of information I told you about. Okay, and based on this piece of information, on the first bullet, I made this graph. Okay, your job is to give me a nice descriptive title, so not just water graph. Okay, I want a descriptive title. And it shows the fresh water and the salt water that is on the planet. And then the same thing for the second one. This one is a graph of just the fresh water on the planet and shows how we have this much in ice, this much locked up in groundwater, and this much locked up in lakes and rivers. Then we have to do our analysis questions. The analysis questions are fairly straightforward. First one says in this activity, use two methods to presenting information about the distribution of water using a model. So that was the video. That's going to be after this one. And then graphing, so above. Okay. What I want you to do is tell me an advantage of these methods. Okay. It is easy is not an advantage. Okay. Or you can make mistakes is not a disadvantage. B, you have to do a disadvantage. I want you to tell me an advantage and a disadvantage of what the experiment or what the graphs tell us, okay? I don't care if a graph is hard to make. I don't care if an experiment, if you can accidentally mess up. We're not saying we're gonna mess up. We're expert scientists. We're not gonna mess up on these experiments. We're asking what is a disadvantage about what the data tells us. Then we have our conclusion. So the conclusion says, state what you have learned about the distribution of water, summarize the results in this lab based on the evidence of this lab. Approximately, I want you to fill in that blank. I want you to fill up how much, what percentage of all the water on Earth is drinkable. Hint, the answer is not 1%, okay? And this is shown by the following evidence. So just give me a brief description of why it's not, or why it is that value. And then this one is kind of an opinion question, so give me a good reason why you come up with your opinion. Based on the evidence of this lab, are you concerned there will be enough fresh water for future generations? Explain your answer using the results from this lab. Like all the other ones, here is your rubric. I'm giving you one mark for writing your name and your class. Okay, so the title page. 2 marks for the hypothesis. Try to use if, then, because. 1 mark for your observations. So just give me some descriptive titles. 2 marks. So 1 mark for each of the descriptive titles on the graph. Data, 2 marks for the percentages. Correct values entered. Oops. I'm gonna have to take off the percentages on the graph. You're not gonna have the percentages on there. If they are there, well, then I'll just remove this. Analysis, 4 marks for, so 1 mark for each valid advantage and disadvantage. Conclusion, 4 marks for the correct percentage listed and valid and thoughtful explanation of what was learned. Conclusion 2, valid answer and thoughtful explanation. So this is the opinion question. And then look at this for some of you, this is the big one. You're not gonna get this mark the way things have been going. Handed in on the due date. Well, the due date is going to be next Wednesday, May 27th. If this lab is not handed in on May 27th, if it's handed in on the 28th, you don't get that mark, okay? So yeah, this is the rubric. The rubric might change. Like I said, I might change this percentage one, so it might end up being out of 18. We'll see if I can edit the graph, but if not, it'll be out of 20. If you like anything, if you have any questions, please send me an email, and yeah, have fun with this. Last lab, I'd like to see everyone do it. It's a very easy lab. Involves a little bit of critical thinking, but I know you guys can do it. I have faith in all of you. Talk to you later. So here we go. Here are the materials that we're going to be using. I've got 1 liter of water right here in my Pyrex container. I've got another Pyrex container that I'm going to use just to hold water. I've got a little syringe that measures up to 10 milliliters. I've got a little medicine eyedropper. It's not the same as what we would be using in class, but it will work. I've got precisely measured out amount of salt right here. It's 29 grams of salt. And I've got a turkey baster, which you can see, I hope, has measurements up to 30 milliliters because I don't have any containers that measure 30 milliliters worth of water, so we're gonna give this a try. So the lab is outlined on page 336 of your textbook, but like I said, we're not gonna be doing exactly like that. So the very first thing we need to do is take this 1,000 milliliters of water, and this water right here, this full 1,000 liter jug, so 1 full liter, is going to represent all of the water on the planet. All of the water. We already said 74% of the planet is water, or we didn't say that, but you're going to learn 74% of the planet is water, and a vast majority of that water is going to be represented in this container right here. What we need to do is predict how much of this water, this full liter, if this was all the water on the planet, how much of it would be drinkable? How much could we drink? Okay, it's very interesting question. So the very first step we're gonna do with this lab is I'm going to take out of this 30 milliliters of water. So I'm gonna give this a try. I'm gonna stick the turkey baster in there until it gets up to 30 milliliters. And oh my goodness, am I good? Oops, not that good. I'm gonna take that out, and I'm gonna transfer it into here, okay? So I wonder why I did that. Why did I do that? Why did I take 30 milliliters out of here and put it all in here? Well, let's go and figure out by using the next step, okay? The next step says, take the salt, that is precisely 29 grams that I measured out, and we're gonna take this and we're gonna stick it into there, and we're gonna use this to stir it, even though we're supposed to use a stir stick. Don't make sure you use proper equipment, okay? But we're using that. So, what do you think this 970 milliliters of water represents? What do you think that represents? I got my daughter here. What do you think that represents? Out of all the water that's on this planet, what do you think this represents? Where is that water located? She whispered the ocean, and that is exactly it. This represents all of the water that is in our oceans. It's all the salt water, okay? Can we drink salt water? No, we cannot drink salt water. So we're gonna stick this off to the side. That's salt water. This right here, the 30 milliliters, this represents all of the fresh water on the planet. Okay, so now we're gonna go through our next step. Okay, this is all the fresh water that's in the planet. What I'm going to do now is I'm going to remove a certain amount of water from there. So it's 30 milliliters. I'm going to go and take out 6 milliliters. Okay, so I'm gonna take out 6 milliliters. Okay, so right here we have the 30 milliliters. I'm gonna use my nice Rexall syringe, pull up. And there we go. I've got 6 milliliters. As you can see, 6 milliliters, okay? And I'm gonna take that and I'm gonna put it into another beaker or into another container, which my daughter brought here. Okay, it should be a smaller one, but that'll work, okay? So I'm gonna take that, and now I've got, right here, there was 30 milliliters, and I've taken out 6. I've taken this out. What do we think that represents? We're gonna do a little hint here. I'm gonna take this. I'm gonna go over to my fridge. Ooh, you guys can see my empty freezer, and I'm gonna put this into the freezer. What do you think that leftover water represented? That leftover water represents all of the water on the planet that's locked up in ice caps. So that leaves 6 milliliters of water, not much, you can see it at the bottom here, 6 milliliters of water that is free and available for us to drink. Is that correct? No, that is not correct, because a lot of that water is also locked up into groundwater, okay? So what I'm gonna do now is I'm gonna take out a little sample of water from here, and I'm gonna ask my partner here, my daughter, to hold out her hand, and I'm gonna, no, hold out her hand, and I'm gonna drop some water onto her hand. And the amount of water I drop onto her hand is gonna be the amount of water that's available to drink out of that full liter. There we go. Out of the full liter of water that we had, that I took and we had at the beginning of this experiment, out of that full liter, all the water that's left for us to drink is just that little drop of water that's in our hand, okay? Out of 1 full liter, okay, only 970 milliliters would be locked up in as ocean water, okay? Then we took out 30 milliliters, we took out 6 milliliters, so that leaves 24 milliliters. It's locked up as ice. And then the remaining 6 milliliters that we had in here, out of that, only 1 drop was, out of the 6 milliliters that are in here, only 1 drop of that would be available for us to drink, okay? So that comes to the question that we have. Should we be worried about the amount of water we have on this planet? Is there enough water for us to drink? Based on this experiment and based on the graphs that you're gonna have on your lab, you're going to have to come up with a, answer some questions and come up with a conclusion. Thank you very much, guys.